The path a bullet takes is influenced by the distance that it travels, but also the distance that it drops based on how much gravity affects it. Let's first talk about the distance traveled horizontally. The distance it traveled is equal to the time that it travels and its velocity. So if you had a situation where it was asking you to calculate the distance of a bullet that's traveling at 600 feet per second, the distance would be equal to 600 feet per second. I'm going to change, they wanted to know for 1 minute. You have to change that to 60 seconds because this is in seconds. And you see that it would travel 36,000 feet. Now let's talk about the distance that it would drop. As the bullet is traveling, it's being pulled down or influenced by gravity. And so the distance that it's going to drop is equal to 1/2 gt squared. G is the gravitational acceleration and is known to be a constant of 32 feet per second squared. And then time is, in this case, since this is in second, this time would be in seconds. So how many feet will a bullet drop in 1.2 seconds? The distance dropped is equal to 1/2 times this 32 times 1/2 squared. And when you do the math on that, you get 23 feet. It would drop 23 feet in 1.2 seconds. So when you're studying ballistics, it's interesting to look at the travel distance and the drop distance over a period of time. So if we're looking at a BB and looking at what's happening as it's traveling 500 feet per second, and we look at different time frames, if we look at the travel distance, we use the equation that travel distance is equal to time times velocity, and you see that the travel distance over this time is 100, 200, and 300 feet. And the drop distance, based on drop distance being equal to 1/2 gt squared, the drop distance is 0.64 feet, 2.54 feet, and 5.76 feet. So if you're asked on a homework problem, what must a sniper consider if the target is 250 feet away? For this bullet to travel 250 feet, it takes about 0.5 seconds. And in that time, it's going to descend, greater than 2.5, less than 5.676 feet. It's going to drop down. So if the person wants to hit their target, they're going to have to take into account that as it is being fired, that the bullet is slowly dropping down. So you'll probably have to raise the gun up slightly higher. And of course, sophisticated guns kind of do all those calculations for you. They'll even take into account the wind speed and the amount of water vapor in the air. Anyway, you'll use these two equations to help you with the homework worksheet that I've created for this activity. This homework worksheet is attached in the assignment section for this day's work.